The universe is filled with billions of galaxies with many different shapes and sizes. This one looks a bit like our home galaxy, the Milky Way. We know that the Milky Way is a flattened disk galaxy with a central bulge, and that our Sun is located about halfway through the disk. But despite many years of study, astronomers still cannot determine many other basic properties of the galaxy, like the position and even the number of its spiral arms. Part of the reason is that our view of much of the galaxy is blocked by huge clouds of dust. Another is that until recently, we had no way to determine the distance to any but the closest stars. In the last 2 decades, NASA and ESA launched 2 amazing instruments to solve these problems and build a detailed map of the Milky Way. NASA's Spitzer Infrared Space Telescope, launched in 2003, looked behind the dust clouds and created a vast panorama of the previously unseen wonders of the galaxy. ESA's Gaia spacecraft, launched in 2013, is the most accurate surveying instrument ever created and has collected data on almost 2 billion stars. Most of these stars fall into this yellow circle in Robert Hertz's famous artist's impression of the Milky Way. The Hertz image shows 4 distinct spiral arms in this region, which shows galactic longitude. Gaia's mapping appears to show a more complex structure. But how do you map 2 billion stars without drowning in the data? One way, pioneered by astronomers Buoy and Alves, is to use 3D meshes to map star density. This image maps the distribution of the main star density clumps in Gaia's second data release. But astronomers can also use Gaia data to map specific kinds of stars or other objects. This image shows the density of ultra-hot O and B type stars, often believed to map the spiral arms. This image shows the distribution of young stellar objects discovered by the Spitzer Space Telescope. Here are clouds of ionized hydrogen gas. Here are dense clouds of dust, and here are vast banks of less dense dust. We can combine all of these objects together to form the beginning of a map of our region of the Milky Way, and even add labels for known regions. But we can do more because these are 3D meshes, and we can use them to build a model that we can fly through and explore.